Hi, how is it going? Welcome to Code with Z. Today's question is LeetCode number 36, valid Sudoku. Now, I want you to know that I'll explain and visualize everything in the coming slides, but for the sake of reading the question, let's see what the question is actually asking us for. So as we can see, we're given a 9x9 board, and we gotta check if it is valid or not. This is what our board would look like, and we have 3 rules that we gotta check, and if these 3 rules are followed and not broken, that means our Sudoku board is valid. The first rule is that each row must contain the digits from 1 to 9 without repetition. So if we have a row that has, for example, 2 8s inside of it, that's not valid, and that's gonna make our Sudoku board invalid. Now the second rule is that each column must contain the digits from 1 to 9, again without repetition. Again, for example, if we have 2 9s in one column, that means our Sudoku board is invalid. Now, the third rule is that each of the 9 3x3 sub-boxes of the grid must contain the digits from 1 to 9 without repetition. Now, this means, for example, as you can see, we have 9 sub-boxes inside of our Sudoku board, and each box should not have any repetition inside of it. So we can't have 2, for example, 3s in one box. Alrighty, let's solve this together, and don't worry, I won't finish this video until I make sure you fully understand how to solve this problem once and for all. So for example, let's say this is our Sudoku board, and if we wanted to get the coordinates of each cell here, we're gonna have something like this. It's literally the same thing. Each cell is gonna have a coordinates that's gonna be like, alright, this cell is in the X row and in the Y column. For example, if we have this here, this is basically corresponding to this position. We're gonna be like, alright, so this is in the row with the index of 0 because our indexes are gonna start from 0. So this is row with the index of 0, this is row with the index of 1, this row has the index of 2, this row has the index of 3, and so on and so forth. And our column are gonna have the same thing. This column is gonna have the index of 0, this column is gonna have the index of 1, this one is gonna have the index of 2, and so on and so forth. And when we're pointing to this position, we're gonna be like, alright, this position is in the row with the index of 0 and in the column with the index of 0. And that's why its coordinates are gonna be 0 and 0. For example, if we were pointing here, we're gonna be like, alright, this position, which is this position here, is basically in the row with the index of 1. So the row with the index of 1, and in the column with the index of, well, let's calculate it. This is the column with the index of 0. This is the column with the index of 1. This is the column with the index of 2. This is the column with the index of 3. And this is the column with the index of 4. So its coordinates are going to be 1, 4 because it's in the row with the index of 1 and it's in the column with the index of 4. And that's why we have 1, 4. Now, we got to basically explore all of the rows that we have here and then explore all of the columns that we have here to check if we have repetitions in our numbers. And when we find a repetition, we're going to return false. And if we don't find any repetitions, we're going to return true. Now we also have to check these sub boxes. As you can see, we have 9 sub boxes that we gotta also check, and each one of these sub boxes should not have any repetitions inside of them as well. But first we're gonna check our columns and rows individually. After we've taken care of these two, we're gonna come back to the sub boxes. So I'll explain the structure of the algorithm and then we're gonna visualize it together. So the first thing that we're gonna have is gonna be a bunch of sets. Why are we gonna have a bunch of sets? Well, we're gonna need them because each time we're gonna loop through our Sudoku board, and when we come across a number, we're gonna check if this number already exists inside of our set. If it does, that means we have repetition, and if it doesn't, we're gonna add it to our set. And this is how we're gonna check for repetitions in our columns, in our rows, and in our sub boxes. So we're gonna have 3 different sets for each one. When we loop through each row, we're gonna add all of the values of that row inside of the row set, and we're gonna be like, have we seen this value before? If we do, that means we have a repetition inside of this row, and we're gonna repeat the same thing for each column, and we're gonna repeat the same thing for each sub box. Now, as you heard me, I said we're gonna loop through stuff, so we're gonna need a loop. This is gonna be representing our loop. Anything inside of it is gonna be inside the loop, and it's gonna be a for loop, so we're gonna have a variable called I, and we're gonna keep on looping as long as I is smaller than 9. Why 9? Because we only have 9 rows and 9 columns. So inside of this, we're gonna have another for loop, and this for loop is gonna have the variable of j, and it's gonna keep on looping as long as j is smaller than 9. Why do we need these two? Well, as you can see, we have 2 values for our coordinates. One is representing the rows, and one is representing the columns. So we gotta have 2 loops so we can make sure that we actually loop through all of the values that we have inside of our board. Now, when we wanna get the values, we're gonna be like, our row value is gonna be equal to board at the index of I and at the index of j. Now don't worry about anything because I'll visualize how this works in a bit. But for example, if I is 1 and j is 2, we're gonna be like, all right, I is 1 and j is 2, so we're gonna have this value at this position here. Now for getting our column values, we're gonna be like, it's gonna be equal to board at the index of j and at the index of I. So for example, if j is 2 and I is 0, we're gonna be like, all right, we're pointing to this position and we're gonna get the value that's inside of this position. That's gonna be equal to our column value. Now, below these, we're gonna be like, have we seen this row value before? So does it exist inside of our set? If it does, that means we have repetition, so we're gonna return false. And if it doesn't, meaning else, we're gonna add it to our set because that means it's the first time we're actually going through this value and we wanna add it to our set so we can check in future if we're gonna come across the same number or not. Now, this was for our row value. We're gonna literally have the same thing for our column value. We're gonna be like, have you seen this call value before? If we do, return false, else, add it to our set. Now let's visualize a few values together. So for example, if our I is equal to 0 and our j is equal to 0, that means our row value is gonna be 0, 0, and our call value is gonna be pointing to 0, 0 as well. That means we're gonna have this as our row value and our call value. But for example, if our j is equal to 1, our row value is gonna be equal to the value at this position, meaning board of 0 and 1. And that's gonna be here, board of 0 and 1. So any value or number that's in this position, that's gonna be equal to our row value, and our call value is gonna be 1 and 0. Why 1 and 0? Because it's j and I, as you can see. J comes first for our call value, so it's gonna be 1 and 0, and that's gonna give us this number. So as you can see, we're actually looping through the rows one by one, and we're looping through the columns one by one. For example, if we keep on going, and if our j is equal to 2, that's gonna make row value be equal to the value at this position, and that's going to be this position, and our call value is going to be equal to the value at this position, and that's going to be this. As you can see, we start from here and we kept on expanding. Currently we're checking the row with the index of 0 and we're checking the column with the index of 0. And if we keep on looping, we're going to check this row and then this column, and then we're going to check this row and then this column, then this one and this, and we're going to keep on looping until we reach the very end when I and j are gonna both be greater than 9. Now these two loops here take care of the first and second rule that we had, because in the first and second rule we said that we shouldn't have any repetitions in our rows and columns, and these two loops are gonna check for all of those. Now what about our third rule? In our third rule, we're gonna be checking these sub boxes here. As you can see, we have 9 of them, and we gotta check, for example, inside of this sub box here, if we have any repetitions or not. Since we've already checked our rows and columns individually using these two loops, and now we're checking these sub boxes, we can actually zoom out a little bit and consider each one of these sub boxes as one element. Now, what do I mean by this? Well, for example, this sub box here is actually at the column with the index of 0. As you can see, if we consider all of this one column and then this one another column, and then this one another column, we have the column with the index of 0, then we have the column with the index of 1. So for example, if we wanted to check this sub box here, this sub box is literally at the column with the index of 0 and at the row with the index of 0. Why? Because we're checking for sub boxes here. So you can easily say we have 3 rows and 3 columns, and these have 9 sub boxes inside of them. For example, this sub box here is at the column with the index of 2. Why? Because this is the column with the index of 0, this is the column with the index of 1, and this is the column with the index of 2. And it is at the row with the index of 1. Why? Because this is the row with the index of 0, this is the row with the index of 1. So the coordinates of this sub box can actually be 2 and 1. And this is how we're going to refer to our sub boxes. So for example, if we wanted to check the values inside of this sub box, we're going to be like, all right, this sub box is at the row with the index of 1 and at the column with the index of 1. And this is how we basically refer to our sub boxes. Now we're going to use this way of thinking to our advantage, and we're going to use it to actually build the structure of our algorithm. I'll explain the structure of the algorithm, and then we're going to visualize it together. So below these, we're going to have another loop. They're not inside of each other. This is actually below our previous loops. And this loop is also going to be a for loop, and it's going to have a variable called box row. And you're going to see a lot of similarities between these two parts. So this is going to be box row, and we're going to keep on looping as long as box row is smaller than 3. Why 3? Because in each row of the boxes, we only have 3 boxes. Box number 1, box number 2, box number 3. So this is gonna be representing the rows of our boxes, and then inside of it we're gonna have another loop, and this is gonna be representing the columns of the boxes, and we're gonna keep on looping as long as box of col is smaller than 3. Again, why 3? Because we have 3 boxes inside of each column. As you can see, box number 1, box number 2, and box number 3. Now these two are gonna give us the coordinates of each box, and when we actually reach the box, we gotta check all of the 9 values inside of each box. So for doing this, we're gonna have another for loop inside of this one, and it's gonna have the variable of I, and it's gonna keep on looping as long as I is smaller than 3. And then we're gonna have our final for loop inside of this, and this is gonna have the variable of j, and we're gonna keep on looping as long as j is smaller than 3. Now don't worry about time complexity, because we have time complexity of constant time, because these are not ends or variables, these are constant numbers. So the first 2 loops are gonna give us the coordinates of the subboxes, and then these 2 are gonna check all of the values inside of the subbox that we found. So here we're gonna be like, current value is gonna be equal to board of box row multiplied by 3 plus I, and don't worry, you're gonna see how this calculation works in a bit, and box col multiplied by 3 plus j, and then this is gonna give us the value inside of our subbox, and then we're gonna be like, have we seen this current value before? If we have, return false, else add it to our set. Now let's visualize a few values together. So for example, if we wanted to check the values inside of this subbox, we can see that this subbox is in the row with the index of 0 and is in the column with the index of 0, right? So we're gonna be like, all right, in our loop, whenever our box row is equal to 0 and our box col is equal to 0, because again, remember, it's in the row with the index of 0 and it's in the column with the index of 0. These 2 values are gonna make our calculations look like this. So box of row is gonna be 0, so it's gonna be 0 multiplied by 3, and box of col is gonna be also 0, so that's gonna make it 0 multiplied by 3 as well, and this is gonna give us 0 and 0, right? And then when our I, for example, is 0 and our j is 0, that means we're in the beginning of our loop, we're gonna have 0 plus 0 and 0 plus 0, and this is gonna give us this position. And as you can see, this position is inside of this subbox. And each time when we loop, we're gonna check all of the values inside of this subbox, and then box row and box col are gonna get incremented, and then we're gonna check all of the other subboxes. So for example, if our box row is 1 and if our box col is 2, that's gonna make our calculation look like this. So this is gonna be 1 multiplied by 3, and this is gonna be 2 multiplied by 3. This is gonna give us 3, and this is gonna give us 6. And if we check, these 2 values are saying that we're gonna check the subbox that has the row with the index of 1. Well, let's check the row with the index of 1. So this row, and the column with the index of 2. So this column, that means we're checking this subbox here. And if you check, 3 and 6 are literally the values of the first position. And this is what our calculation is doing. With the values of box row and box col, we literally get to the first position inside of the subbox, and then when we add I and j to them, it's gonna actually move it so we can actually check all of the values inside of the subbox. So for example, if our I is 0 and our j is 0, that's gonna make this be equal to 3 and 6. That means we're gonna be checking this first position here. But for example, if our I is 1 and our j is still 0, we're gonna have 3 plus 1 and 6 plus 0, and that's gonna give us 4 and 6, like so. And 4 and 6 are gonna be pointing to this position, as you can see, because our box of row and box of col are pointing to this subbox. No matter how much we actually change our j and I, we're gonna stay inside of this subbox. And when we're done, our box of col and row are gonna get incremented, and then we're gonna move on to the next subbox. If we come across any repetitions through our code here, we're gonna return false, and if not, that means our Sudoku board is valid, and at the end we're gonna return true. Now let's code this in the simplest way possible. Alrighty, so the first thing that we're gonna have is gonna be our first for a loop, just like we saw in the slides. So I be equal to 0, we wanna keep on looping as long as I is smaller than 9. And then we wanna keep on incrementing I on each round. Now here, we're gonna define our sets, one for rows and one for columns. So we're gonna say const visited values row. This is gonna be equal to a new set. And then we're gonna below this have const visited values of col. And this is gonna be again another set, like so. And then below these, we're gonna have our next loop, and this is gonna be j equal to 0. We want to keep on looping as long as j is smaller than 9, and then we want to keep on incrementing j on each round. Now here we're gonna grab our row value, and this is gonna be equal to board of I and j, just like we saw on the slides. And then below this we're gonna have our call value, and this is gonna be equal to board of j and I. Now below this we gotta check if we've seen these values before or not. But first, we gotta check if we do actually have a value, because as you can see, some of these cells here are literally empty, and we can see this from our input as well. For example, if we have a number, it's gonna be actually a number in string form, and if we don't, it's gonna have a dot. So we can actually use this to our advantage and say, if row value is not equal to a dot, we gotta check if we've seen it before or not. So we're gonna say if visited values row, meaning if our set has this row value, return false. Literally, if we've seen this value, meaning if this value is already inside of this set that we defined, return false. And else, we're gonna say add the value that we currently have to our set. Literally, add row value, like so. And then we're gonna have the same thing for the call value. We're gonna say if call value is not equal to a dot, do the following: if visited values call has call value, return false. And else visited values call dot add call value, meaning we want to add this value to our set if we've not seen it, and if we've already visited it, we want to return false. Now this actually takes care of the first and second rule, just like we saw in the slides. And then below this, we're gonna have another loop. This time we're gonna say for let box row be equal to 0. We want to keep on looping as long as box row is smaller than 3, and we want to increment box row on each round, like so. And then inside of this, we're gonna say for let box call, just like we saw on the slides, be equal to 0. We want to keep on looping as long as box call is smaller than 3, and we want to increment box call on each round. And then we're gonna get inside of this, and we're gonna define our set. We're gonna say const visited values box is equal to a new set. Literally the same thing. And then here, we're gonna check all of the values that we have inside of our box. So we're gonna have another loop, and we're gonna say for let I be equal to 0. We wanna keep on looping as long as I is smaller than 3. And then we wanna keep on incrementing I on each round. And then below this, we're gonna say for let j be equal to 0. We wanna keep on looping as long as j is smaller than 3. And then we wanna keep on incrementing j. Here, we're gonna get our current value. And this is gonna be equal to, just like we saw on the slides, board of 2 values. Here, we're gonna say box row multiplied by 3 plus I. And here, let me drag this to the left. So box row multiplied by 3 plus I. And here, we're gonna say box call multiply by 3 plus j, like so. And this is gonna give us our current value. Let me scroll down a bit, and here we're gonna check if our current value is actually a number. So if current value is not equal to a dot, do the following. We're gonna have the same logic here. We're gonna say if visited values box dot has current value, return false. Else we gotta add that value to our set. So we're gonna say add of current value, like so. And then at the end, if we don't actually have any problems and we don't return false anywhere, we're gonna return true. Now let me zoom out. I hope I have not made any typos. This is all of our code. Let me zoom out once more, and again once more, because our code is pretty long, as you can see. Now let's run this and see if we're gonna get accepted. Yep, as you can see, both of them are passed. Now let's submit it. Moment of truth. Let me get this down. And yep, accepted, and we're beating 82% of all of the other submissions. Thanks for watching. Don't forget to like and subscribe, and keep on coding.